It may seem that electron configuration is an obscure branch of chemistry, but in fact the entire periodic table is aligned to it. We have the S group here, the P group here, the D group here, the F group here. 3 more atoms, I should say elements to be discovered, and we'll have to throw in the G group. Let's take a look at electron configuration and how it is mirrored by the periodic table. The first 2 electrons around an atom go into the 1s orbital. That would be the electron configuration of helium, and it would look like that. Add 2 more electrons, and we go into the 2s orbital right there. 2p6. There's the 3p subgroups, and we're now at neon. We're going to work our way all the way through the entire periodic table and actually a little bit beyond, so get ready. 3s2. There's our 3rd shell right there. We're going now to 3s2. Let's add the 6 electrons of the 3p subgroups, 3p sub x, 3p sub y, 3p sub z, and we're now at argon. The 4th shell begins to populate with the 2 electrons, but it turns out that there's a lower energy shell that comes next, and it's within. We're not always working our way out. We now have the 5 orbitals that comprise the D group. 3D sub whatever. Notice that they're a little smaller in radius, at least that's how I'm modeling them. And there's 5 sets, each with 2 electrons. Very strange shapes, but we're now out to zinc, 3d10. We go back up to the 4th shell and have 3p groups. And that's where the electrons would be in up to krypton. The 5th shell has 2 electrons in the s group. Then we drop down a shell, and we're going to go to the 4d group. 1, 2, 3, 4, 5. Back up to 5p, 2, 4, 6 there. And we have the electron configuration of xenon, ends in 5p6. Let's keep going. 6th shell, 2 electrons, but then drop 2 shells down to the F group. A pattern within a pattern. We're now dropping 2 shells. Before we dropped 1 shell, but it's a pattern. And this one has 7 subshells. 1, 2, 3, 4, 5, 6, 7. Work our way back up to here, and we have the 5D shell. That should be 5 pairs. 1, 2, 3, 4, 5. We're now at, is that silver? No, it's something else. Mercury, perhaps. And we are now at 5D10. We need 6 more electrons to work our way up to radon. And so we'll do the 5px, 5py, 5pz, and we're at radon. Got to keep going. 7th shell. 2 electrons in the 7th. That's the S subshell. And then a set of 7 in the 5F. See, that's where we're going from 7S down to 5F. Let's do the 5F orbital groups. There are 7 of them. 1, 2, 3, 4, 5, 6, 7. We should be now going up to 6D, which is 5 subgroups. 1, 2, 3, 4, 5. And that is now up to some, well, it's an old periodic table, some elements that weren't named officially at that point. Finally, if we do the last 6 electrons, it should bring us to oganesson, which is element number 118. And that's the electron configuration of the largest element yet to be discovered. It does go on in a beautiful pattern. I'm just going to wing through it. And we keep rolling, and it gets very beautiful. We're seeing the G subgroup now. Okay, now if you want to follow this with the periodic table, it's great. And it works its way up to 7p6, and it's pretty easy to do. But if you want to take it forever, this little drawing here shows you the infinite pattern of the Aufbau order. For instance, here we are up to 7p6. What should come next? Well, if you draw it out like this, and there's other ways to do it, this is perhaps one of the easiest though, just fill in the blanks. It's going diagonally, 1s2, 2s2, 2p6, etc. So I guess we're going to go to 8s2 next. That would be there and there. Maybe you'll be the one to discover them. You can give them your own name. What would come next? Well, we got to go up to here. That must be a new letter. It's going to be called G. It'll consist of 18 electrons as you work your way across. I envision a big row of a couple of them here, and they're 18 across. Next one would be this one. Just follow the pattern. 7d, 8p, and 9s. And believe me, that would be a lot of electrons in a system. And it would be hopelessly unstable, which is a bit sad, but that's the way it is. So that's the correlation between where the electrons are and how the periodic table shows them using the Aufbau order.